Every single time you turn on your phone or your laptop or even your watch, there's this invisible hero working like crazy behind the scenes. It's the master manager running the entire show, but honestly, most of us never give it a second thought. So today, we're going to pull back that curtain and take a look at the operating system.
Really think about it. You click on your web browser and poof, it's there. You're typing an email, you've got music playing, a notification pops up. How in the world does your computer juggle all of that at once without just, completely freaking out? It feels a lot like magic, but it's not. It's just a really, really clever piece of software.
And that software is the operating system, or OS for short. It's the answer to how all that magic happens. So, the best way to think about the OS is as the master manager of your computer. It's the critical piece of software that stands between you and the physical hardware. It translates all your clicks and taps into a language the processor, the memory, and the screen can actually understand. Without it, your laptop is basically just an expensive paperweight.
And look, you already know all the big names here, even if you don't really think of them as these managers. You've got Windows, Mac OS, and Linux running our desktops. And of course, you've got Android and iOS, which run those supercomputers we carry around in our pockets. They all have the same basic job, they just have different ways of doing it. So what does this master manager actually do all day? Well, like any good manager, it has a core set of responsibilities that it has to nail to keep the whole operation running smoothly.
Okay, so let's break this down, because this is where the real work gets done. First, the OS is an incredible multitasker. It's constantly juggling every single program you have open. That's task management. It's deciding millisecond by millisecond which program gets to use the computer's brain. It's also in charge of memory, giving each program its own little sandbox of RAM to play in. Plus, it's the librarian, keeping track of every single file so you can find that photo from 3 years ago. It controls all your hardware, your keyboard, your printer, you name it. And finally, it's your security guard, using passwords and permissions to keep everything safe. It's a busy job.
Now, to pull off this incredible juggling act, the OS has a really clever trick. It breaks big jobs down into smaller ones. So a process is the whole program that's running. Think of your entire web browser. But a thread is a smaller piece of that job, like a single tab you have open in that browser. By running lots of these threads at the same time, your computer feels super fast and responsive, even when it's doing a million things at once.
Okay, so we know what the manager does, but how is the manager's office actually set up? Let's peek inside the architecture of the OS itself. For the most part, it's built in 3 main layers. Up at the top, you've got the application layer. That's all the stuff you actually interact with: your browser, your games, your spreadsheets. Then in the middle is the shell. This is how you talk to the manager, either through a nice graphical interface with icons and windows, or for the pros, a text-based command line. But down at the very bottom, you have the heart of the entire system, the kernel. This is the manager's core brain. It has total control and talks directly to the hardware. Everything else is built on top of it.
But get this, not all kernels are created equal. They have different, management philosophies. A monolithic kernel, like the one in Linux, is like a manager who does everything themselves in one huge, super efficient program. It's a big reason Linux is so famously fast and stable. On the other hand, you have a hybrid kernel, which is what you'll find in Windows and Mac OS. It's more of a mix. It keeps the really critical stuff for itself, but delegates other tasks out. This makes it a bit more flexible. Each style has its own pros and cons when it comes to performance and complexity.
And just like you'd hire a different manager for a creative agency than you would for a factory, there isn't one single OS that's perfect for every job. You've got specialized managers for pretty much anything you can think of.
For instance, a real-time OS is for jobs where timing is everything. We're talking medical robots or the flight controls in a fighter jet, where even a millisecond delay could be a disaster. A network OS is built to manage all the resources for a whole office full of computers. A distributed OS goes even bigger. It makes a whole bunch of separate computers act like one massive supercomputer. And of course, we've got mobile OSs, built from the ground up for touchscreens and saving battery life.
Now, all this incredible variety didn't just appear out of thin air. The role of the OS has changed so much over the years. So let's just do a quick trip down the timeline to see how we actually got here.
In the beginning, way back in the 50s, computers were these giant room-sized things that could only run one single job at a time, no interaction at all. Then, the 70s brought us the legendary Unix, which introduced the wild idea that a computer could handle multiple users and multiple tasks. But the real game changer? That came in the 80s, with the graphical user interface, the GUI, from Apple and Microsoft. All of a sudden, with icons and a mouse, anyone could use a computer. From that point on, the story has been all about connection, to the internet, to the cloud, and to each other.
So what's next? What does the future hold for our master manager? Well, its job description is definitely about to change all over again.
Yeah, we're seeing some really amazing things on the horizon. Operating systems are getting way smarter, with AI being baked right in to try and figure out what you need before you do. Many are moving to the cloud, where all the heavy lifting happens on massive servers instead of on your device. We're going to need completely new kinds of OSs to handle the mind-bending world of quantum computers. And there's this huge push for systems that are open source, ultra-secure, and super lightweight for the billions of tiny smart devices that are everywhere now. And all of that leads to one final, really interesting question. As our devices get smarter and are constantly connected to the cloud, this manager is getting more powerful, but at the same time, it's becoming more and more invisible. So will the OS as we know it, that thing that lives on your machine, eventually just fade into the background? Will it become this seamless, intelligent service that just works no matter where you are? Something to think about the next time you click an icon.